Okay, go.
I'm so scared.
What can happen? It can explode and kill us all.
Shut
but
up, Ayana.
no pressure.
You're ruining the scientific.
You kind of are.
Oh, whoops.
It's fizzling like at the top, but
I'm afraid the can's gonna like burn because I did this in class.
it's not steaming. See, it's boiling at the top with the excess water.
Mhm.
So it should be steaming in like a few minutes, seconds.
Just saying, Brenda, maybe you shouldn't stand so close.
I'm just saying.
I mean, I smell. Oh, sorry.
Hi.
You say Bill not a science guy?
Maybe we need a real Bunsen burner. We should.
No, I think that would be fine.
We should have like a big candle or something.
I hear it like.
Oh no.
Oh God.
Oh,
I already got
it
it.
sort of worked.
So, temperature and pressure are directly proportional, meaning that if you increase the temperature, you also increase the pressure. The same is true vice versa. So, volume and pressure are inversely proportional, meaning that if you were to increase the volume, you would decrease the pressure. And the same is true vice versa. So, as for moles and volume, if you increase the number of moles, which is the amount, then you also increase the volume. So the reason why is because if you increase temperature, that means that molecules are moving faster and they're colliding more frequently and they're exerting more force on their container. So that's what increases the pressure. And then with volume, if you were to increase the amount of space that the molecules have, then that means that when they bump into each other, it's going to take them longer to exert force on their container. So that means that their pressure isn't going to be as high. With moles, it's basically just if you blow up a balloon, the more air that you put into that balloon, the more volume you're going to get because there's more molecules colliding. And if you were to put in less air, then you're going to get less volume because there's less molecules colliding. So with our project, it was an open container. So when this can got heated up, or when the water vapor in that can got heated up, it left. And so that means that there's less molecules in this can. So that means it has less pressure. When you put it inside the container filled with water, there's a lot more pressure inside that water container because there's a lot more water than there is air in this can. So once you put the can in the water, that means that the pressure inside of here is far less than the pressure outside because there's less molecules, less collisions, less pressure. So that's why it turned into that. So last video, I talked to you guys about pressure. But one thing that I forgot to mention was, when I say pressure, I'm talking about outside pressure. So when the outside pressure is greater than the inside pressure, that causes a decrease in volume. But when the inside pressure is greater than the outside pressure, that causes an increase in volume. So let's think of it like this way. If you're pushing on a balloon, you're going to cause it to decrease in volume. But if you heat that balloon up, that means that the pressure inside the balloon is becoming greater because the molecules are moving faster. So that would lead to an increase in volume.